Hello everyone and welcome to the first distribution that we'll be learning in statistics, the binomial distribution. A binomial distribution is used to model what happens over n independent trials with a probability of success p and a probability of failure 1 minus p. So let's say the trials I'm going to do is rolling a dice. I'm going to roll a 6-sided dice, and if I get a 6, this means I win. Let's say I want to roll this dice 5 times. Then n, which is your number of repeated independent trials, will just be 5. And my probability of success is 1 over 6. Now, if a variable x is binomially distributed, we can write this with x and then a tilde, b, and then n comma p. This b just represents binomial distribution. Now, before we start going on to the questions, I'm going to cover two more things: the expected value and variance, as well as how to find probabilities. So first, for the expected value and the variance, these two formulas are in your formula booklet. Your expected value is n times p, n times p. And your variance is n times p times 1 minus p. Now, I would like you to note the expected number over here and the most likely number are two completely different things. Expected number refers to the expected value or the mean, while most likely refers to the mode. I want you to take note of this when we're going through the questions later. Now here we come to the GDC part for binomial distribution. How are we going to use the GDC to help us find the probabilities? Now, to find the probability of x equals to x, I'll use this thing called the binom PDF. So to find the probability that x equals to x, I'll write this in the calculator. Binom PDF bracket n comma p comma x close bracket. So this can mean something like the probability that I get, let's say a 6, 5 times out of 10 rolls. So over here, your probability is 1/6. N is your number of trials, so you're rolling 10 times. And you want to find the probability of me rolling this 6 5 times. So that's why you key into the calculator. Now to find the probability that this variable x lands between A and B, we'll write binom CDF, NPAB. What does this all mean? Let's say I want to find the probability that I roll a 6, let's say 3 to 7 times out of 10 rolls. Then your A and B that you're going to use over here will be 3 and 7. Got it? Now let's move on to the question. These right here are all the important questions that you need to know about binomial distribution. If you can do all these questions, you are set. Now, the question states, the probability of a pen being drawn at random from a box of pens is defective is 0.1. If 7 pens are drawn, find the probability there are no defective pens. So first, I want to write my statement that x is binomially distributed with n equals to 7. You see we're doing 7 different trials, and the probability of success, which is the probability of your pen being defective, is just 0.1. Now we want to find the probability that there are no defective pens. So out of this box of 7 pens, we want to get 0 defective pens. We will just be doing binom PDF 7, P 0.1, and 0. Because you want to find the probability that we're drawing 0 defective pens. Now in the GDC calculator, let's type in binom PDF, and then we'll type in 7, 0.1, and 0. And that gives us 0.478. Now the next one, if 7 pens are drawn, find the probability that there are less than 2 defective pens. The probability that there are less than 2 defective pens, Px is less than 2, is actually the same as the probability of getting 1 or less. Because again, if it's less than 2, it can only be 0 or 1. Now I'll use binom CDF and then 7, 0.1, again, NP. And over here, 0 to 1 is the number of defective pens that you actually want to draw. So that's the range that we'll be providing over here. For binom CDF, we do a similar thing. Just type in binom CDF 7, 0.1, 0, and 1. Doesn't matter the capitalization. Next, 3 samples of 7 pens are drawn. So over here we drew the 7 pens. Now we want to draw these 7 pens 3 times. Find the probability that he draws less than 2 defective pens in only one of the samples. So what this guy is doing is he's taking 3 different samples of 7 pens, and he only wants less than 2 defective pens in one of these samples. From the earlier question, we know that the probability that there are less than 2 defective pens is 0.850. So now I actually introduce a new variable, let's say y, with samples of 7. Remember, we're just drawing 3 samples of these 7 pens. And our probability of success is when we draw less than 2 defective pens, which we see from this earlier question that this probability of success is just 0.850. We want success in only one of these samples. Since we want only one of the samples, we're going to use Binomial PDF. So the probability of getting only one of these samples is Binomial PDF 3, again n, 0.850, this is your new binomial distribution by the way, and then comma 1, which is 0.0574. Let's go through these two together. These two actually use a technique called the split screen table. So let's look at this. If 7 pens are drawn, find the most likely number of defective pens. Remember from earlier, the most likely number is just your mode, the highest probability. So this is not the same as finding EX. By the way, finding EX or your expected value is just n times P, which is n, 7, times P. That is your expected value, and you're not supposed to round this value. Now let's say I want to use Binomial PDF for this. So you have n, you have P, but you don't have the number of defective pens that you want to draw. So what can we do? We can put a variable x here, and we can vary this variable x. Now if you plot this into the graph and use the split screen function, it basically gives you a way of displaying the values of this for all integer x values. So it will give you the value of Binomial PDF 7, 0.1 when x equals to 1, when x equals to 2, 3, 4, and list on and on. So in your graph, I want you to type in Binomial PDF 7, 0.1, and x. Press enter. There'll be nothing there, but that's okay. Go to the menu, table, and split screen table. Now what this does is vary the values of x for integer values. So we have this over here, and we're varying the x. So when x equals to 0, this gives us the probability that we draw no defective pens, and this probability is 0.478. Similarly, when x equals to 1, this gives the probability that we draw one defective pen, which is Binomial PDF 7, 0.11, and this is 0.372, etc., etc. So in this case, the highest probability or the most likely number is when x equals to 0. This means that the most likely number of defective pens is 0 defective pens. This is the highest probability that we're getting. Now the last question. Find the least number of pens that should be drawn if the probability of at least one defective pen drawn is more than 0.7. Oh wow, this is a lot to take in. Let's break it down. Now we want at least one defective pen, so we want Px is more than or equals to 1. And as such, I want to use Binomial CDF. I'll write 1 over here because I know that the lower bound for the number of defective pens that I want to draw is 1. The number of defective pens that I want to draw must always be more than or equals to 1. Well, we already know the probability is 0.1. And we want this probability that we're getting over here to be more than 0.7. So we write more than 0.7. Now we have two things that we're leaving out here. This is the number of trials. But actually what we're doing is varying our number of trials. We're trying to find the least number of pens. Earlier, we were varying the number of defective pens that we're going to draw. And that's why we put an x here. So I'll put an X here to vary the number of pens that should be drawn, the number of trials that even takes place. And we know if there's at least one defective pen, the upper bound must also be X. To see why, let's say I get a number of 6 over here. What this is doing is finding the probability that I'll get between 1 and 6 pens out of 6 trials. So again, we're going to use our split screen method and plot this onto the graph. So let's type in binom CDF x 0.1, 1, x into the graph, menu table, and split screen table. Now this will vary the integer x again to give the probability of at least one defective pen, given a sample of, let's say, 1 pen, 2 pen, 3 pens, etc. We are trying to find the first value where this probability exceeds 0.7. And aha! We scroll down and we find that x equals to 12 is the first time that this probability exceeds 0.7. This means that my least number of pens has to be 12. Because any lower than that, then the probability of getting at least one defective pen is less than 0.7. Here's a summary sheet for binomial distribution. Thank you so much for watching.